Hi everyone, welcome to the second episode of the tutorials on how to compare machine learning classifiers using Heatmaps. For this tutorial, we are going to compute Auc scores for different multi-class models and use the result to generate a heat map. We are going to use these classifiers here. There are 8 of them: Ada Boost, Extra Trees, K-nearest neighbor, Logistic Regression, Naive Bayes, Random Forest, Support Vector Machines, and XGBoost. The notebook for this tutorial is available on my machine learning repo. So what we are going to do is to run the notebook using our browser. So let's first go to the GitHub repo. This is the page, and I will leave the link to this page in the description box. When you are here, just search for the button here, open in colab. Search for that one, and then just click it, this blue button here. So click it, and then Google Colab will open it for you. You need to make sure you have signed into your Google account, otherwise you may not be able to run this notebook. So take notes. I will switch to my notebook here. We will begin by importing our libraries. So I will use this cell to help me do that. There are comments here to let you know what each group of codes will do. Okay, now we are going to read the data. The data is also available on my machine learning GitHub repo, so I'm reading it directly from there. So I will get the data here. Okay, so I have read the data. Whenever you are going to perform machine learning tasks, it's important to do some exploration. This data set has been used a number of times on my channel, so I will do a little exploration here. So take notes. For the exploration, it helps you to understand your data. Okay, it helps you to get information that will help you to identify or select the relevant methods for the downstream analysis. So it's always important to do data exploration. I'll just do some quick exploration here. So I'll start with the shape. So the shape here will give me the sample size and also the number of features. So I'll say data frame.shape, and then I'll run it. So here I'll have 801 rows, and I also have 8001 columns. The rows here represent the samples. And then the columns here, we have 8001. 8,000 of them are features, and then 1 is for the label. So take notes. So let's proceed. I'll move straight to the data preprocessing. I'll first separate my features from the labels or the class. So I'll do that using this code here. And then I am going to encode my labels. It's always recommended to encode your labels with numbers, with integers. Let's go back here. Let me show you why we are doing that. I'm doing this just in case this is your first time watching this video. Let's check the last column. Let's just say data frame.columns. Let's check the last column. This is the last column. Okay, so this is the label. So let's check some entries here. So data frame.columns, not columns, I'll say data frame. I'll have to give the column name. And then I'll say .head just to get a first 5 entries. So this is how our labels are being represented. Okay, we are dealing with cancer. Okay, so these are cancer types. So this is how they are being represented. So these are categorical data. Okay, and that is why we are going to encode so that we represent these entries with numbers. And so this will help us do it. I'll run this cell to get the encoding done. Perfect, that is done. let's just check it. So let's type labels. This will give me the original labels. Okay, and then the classes here, let's just check it. Okay, so this is how it has been encoded. So we are representing these with these ones here. So take note of that. So it is this scheme, this format that we will feed the machine learning models. Now let's proceed. We are now going to split our data into train and then test sets. So we will do that here. After that, I am going to normalize the data. So with the normalization, it will help us to scale our data between 0 and 1. Okay, and this will help us to improve the model's performance and also avoid bias. I am going to normalize the train and the test set separately. I am doing this so that I can prevent data leakage. So I will get it done here for me. Perfect. Now I'm going to perform feature selection. I have thousands of features here. Okay, when we check the data frame.shape, we got 8,000 features. Okay, so what I want to do is to select the relevant features and then use them for the downstream analysis. And so that is why I'm going to perform feature selection. So let's scroll down. So with the feature selection, there are lots of algorithms available, but I'm going to use the mutual information algorithm. So with the mutual information algorithm, it will compute scores for you, and these scores are the importance of the features. And so using the scores, I'll select the top 300 features and then use them. So that is what I'm going to do here. So I'll need to first compute the mutual information scores. So I'll do that using this cell. Okay, I have done that. So I am now going to select the top 300 features. So that is why I have defined my end features here. And then for this line here, this code here will sort the scores that we have here. Okay, it will sort them, and then after sorting, I'll now select my top 300 features. Okay, so the sorting will be done in descending order. Okay, so from the largest to the lowest, and then I'll select the top 300 features. So what this is doing is that NumPy will do the sorting all right, and it will also keep the indices of those scores so that we can use those indices to do the final selection. So that is what we are doing here. You can also modify this value here. I mean, you can just try and then see what comes up. So it's up to you, but I'll use 300 here. Now I'm going to select the features. Let's do it here. Now I'm going to select the features. So I'll do that using information from this side. So I will select, and notice that I have used a suffix here, selected. This will help me to differentiate between the selected features and the original train and then test sets. So that's what I'm doing. It's always important to have a naming convention. This will help you a lot. So I'll get the selected features. Perfect. Now I'm going to perform the model training and evaluation. Okay, so after training, we do evaluation. Evaluation is where we compute the AUC scores and then generate the heat map. Because I'm dealing with multiple classifiers, I need to find a way to automate the task. And that is why I'm using functions here. So I have two functions. One of them will compute the AUC scores, and then the other is going to be used to fit the model to the training data. I'll start with this one here. So this function here will take the model. It will also take in the tests and then the Y tests. Okay, so that's the test set. and then after getting it, it will now compute the AUC scores. And so what is happening is that this model here is the trained model. Okay, that's the trained model. So after training, we feed this, we call this function, and then we supply it with a trained model, and then it will do its work. I also have this group of codes here. Now with AUC scores, these are calculated from probabilities. Okay, for the machine learning models, some use the decision function method, others use the predict proba method. And so what the codes here are doing is that they will check to see if a model uses the decision function or the predict proba function, and then it will compute the probabilities for us. So that's basically about it. This is also a way to help me to automate the process. So let's proceed. After that, I have this y-test binarized here. When we compute the probabilities, because it's multi-class, we are going to get probabilities for each class. Okay. And with the probabilities, because we are getting it from each class, we also need to make sure we have formatted our y-tests. Okay, that's the labels. Okay, for the test set, we need to also format it so that it has the same shape as the probabilities here, and then we can be able to compute the AUC scores. The AUC scores are going to be computed for each class. Okay, it's going to be done separately for each class. So that is why we need to get our y-test into an appropriate format so that we can use that here. So that is what we are doing here. Here is still the same. Okay, I have already covered a tutorial on how to generate ROC curves for multi-class models. So the explanation is already there. You can go check it out. So I'm basically reusing that code here, and then just modifying it so that I can use it for multiple models. So take note of that. Okay, so I will proceed. Now let's look at this function. So this function will take the training sets and then fit the models to the training sets and then return the trained models to us. Okay, so after fitting the models to the training sets, we have the return keyword here to return the trained models for us. Notice I also have a dictionary here. So this dictionary here, after training the models, the dictionary will store the models and also label them for me. So I have some names here that I'm using. Okay, so I have the labels here, and then these labels will help me to be able to call the models anytime I want. So take note of that. So I'll run this cell to also get that function. Actually, let me start from here. Let me get this one first and then get this one also. Perfect. So I now have my functions created. Okay, now we are going to proceed. Let's go back here. Let's look at the compute AUC. The compute AUC here will also return the AUC scores for us. I made mention that the AUC scores will be computed for each class. And so there is a dictionary here that is used to store the AUC values. That is what we have here. This one, we can use it to plot ROC curves. So I placed that one here so that you can always modify this code to generate the plot. But for this tutorial, we are not going to generate the plots anyway. We just generate the AUC scores. So take note of that. So it will return the scores for us in a dictionary form. So the dictionary form lets us get the AUC scores for each of the classes. So take note of that. Now let's proceed. we are now at the final stages. What we are going to do now is first create an empty dictionary. You say AUC scores, or this will be an empty dictionary. This dictionary will be used to store the AUC scores for all the models. So after we have called the function here, we will then store the results here. That is what we have here. Okay, so we will have this scores, okay, the AUC scores all. Perfect. Now we are going to call the fixed data function here first, so that we can train the model. So I will say trained models equals fixed data. Then I will supply the training sets. Remember, we did a subset here, perform feature selection, so we are using the X-train selected. So we will put that here, X-train selected. And then we will say Y-train. So let's get the trained models. In other words, we are training the model now. Okay, we now have our models trained. So let's check. Let's just check the data type. It's supposed to be a dictionary object. Perfect. So if it's a dictionary, then we can get the models. Let's get the names. So let's say train models dot keys. Perfect. So we have the names here. Okay. Now we are going to call the compute AUC function here. And when we call it, we will supply it with the train model and then the test set. That's what we are going to do here. And because we have 8 models here, we also have to use a loop so that we can iterate over each of the models and then send them. So we are going to say for name model in trained models.items. This is the dictionary, so this is the key value pair. And then we say AUC scores equals, and then we say what compute AUC. We supply it with the model, and we say X test selected, and then Y test. And after getting the scores, we now store in this dictionary. So we say AUC scores all name, the name of the model equals AUC scores, like this. So let's run it. Perfect. So we have the scores. Now let's check. Let's say AUC scores all dot keys. We have the models here, the names. So now we can call the AUC scores for a particular model. Let's just say Adabus. We can say AUC scores all, and we call Adabus. And this will give us the scores. Okay. I also made a modification in that code so that instead of returning the class, the numbers themselves, we will get the original labels. Okay, this will help us to easily understand and interpret the results. So that's why you have the BRCSU reading and others there instead of the class itself, the numbers that we used, okay, for the encoding. Okay, so take note of that. So let's proceed. Now we have them here. You can also query and get the AUC scores for a particular class, for a particular model. So we can still say we want AUC scores for the BRCA class, okay, and that was obtained from the other boost model. So we can add this BRCA, and then we will get the AUC score for that class as well. Okay, so that's how we do it. Perfect. We are doing a great job, people. Let's keep the fire burning. Okay, we can also display everything. We can just say AUC scores all, and then we get everything here. Okay, so we have that also done. Perfect. Now we are almost there. We are now going to generate a data frame. What we have here is additional objects, but if you want to manipulate further, and if you also want to save or store the output, to store the result to an output file, then we need to put it in a proper format. So we are going to generate a data frame, which is basically a table. Okay, we are using pandas. So we can say pd.data frame, and we say AUC scores all. This will give us a table. Perfect. Okay, so we have a table here which is more presentable than this dictionary here. Okay, so if you have the table here, it becomes easy to read and then make inferences here. Okay, now what we did was to just issue the command. So we can actually assign the result to a variable. So we can say scores. I'll just copy and paste it. You can say scores equals, and then we supply it this way, and then we can run it. So after running the command, we can just query for it again. Perfect. So now we have it here. Okay. So it's nicely done for us. So because it's a pandas data frame, you can save it to an output file, a CSV file or whatever. Okay. Or you can also make some queries here, but that is for another day. Now let's proceed. We are now going to generate a heat map using the AUC scores. We will use Seaborn and Matplotlib to generate the heat map. So let's proceed. So I will say sns.heatmap, and then I'll supply it with the data frame. And then I'll use a color map of blues. Perfect. So I have it done for me. Okay, so I have the heat map here. We can add more information. We can include the scores in this heat map. So to include the scores, let's just do it again. To include the scores, let me just use a different cell. To include the scores, we can say are equals true, and then we will get the scores. Perfect. Let's add labels. We have our classes here. We also have our classifiers here. Okay, so we can add additional information to this plot. So let's plot it here. Let's add, we say plt.xlabel. That'll be hot. Classifier or classifiers. Let's just say classifier. And then plt.y label class. Okay, so let's just say classifiers, and let's see labels. Let's use this rather. Okay, so let's run this command. Let's check to see that everything is okay. Perfect. So now we have everything here. Okay. Perfect. So we have the plots done nicely for us. Let's go back to the table. This is what we have. Let's just say you want to swap. You want the classifiers to rather be on the y-axis and then the labels to be on the x-axis. You can still do that here. And so with that one, we still have to go back. What we need to do is to transpose this table here. And so we will do the transpose here. We can still say, we will use the same command, and this time we will say dot transpose, and then we run it. So now if you generate the scores, you see that there has been a change. And so from there, we can use the same command here. And then this time, the X becomes the labels, and then the Y becomes the classifiers, and then we run it. Perfect. So now we have everything done nicely for us. So this is how we generate heat maps for multiple classifiers using Auc Scores. Okay, perfect. So now you have another way you can use to generate heat maps for machine learning classifiers and use that to compare the performance of those classifiers. So that will be all for this tutorial. Thanks for watching, and I'll see you in the next session. Goodbye.